on page 8, you'll see the measure of a spread, and we're going to be using, like, we call this a normal distribution. So we're only going to be going out 3 standard deviations to the right and 3 standard deviations to the left. Okay. So first thing we're going to do is read what it says at the top. It says, on the number line of the graph below, label the middle by writing the mean number, which is 4. Okay, so this number here is 4. So your mean is always in the middle of your bell curve. Okay, so I'm just going to put mean. Okay, so that number that's right in the middle, because again, we're always comparing everything to the average. Then, using the size of one standard deviation of 2 years as a scale, so that means little sigma equals to 2, label the number line on the graph below -3 standard deviations to the right and to the left. So we're going out plus or minus 3 deviations, which means our scale we're counting by will be 2, because that's, this is like your scale. So this will be 6. Okay, pretty simple. The next dot will be 8, and the next is 10. So make sure you know this will be considered 1 standard deviation. So I'm going to put +1. Little sigma stands for standard deviation. Okay, +2 and +3. Okay, so now we're going to go to the left. So we're going to subtract 2, because that's our scale or our standard deviation. That's 2, 0, and -2. So this will be -1 standard deviation, -2, and 3. And when you are doing your project for this particular unit, you're going to have to set up your bell curve the exact same way. So you will take your mean and your data, put it in the middle, determine what your standard deviation is, which will be your scale that you'll place at the bottom of your bell curve. So the first question asks, how many standard deviations away from the mean is the dog that is 6 years old? Okay, well, here's 6 right here. So here's our mean. So how many standard deviations would you say? It's just 1 standard deviation away. Okay, because you just count over to the next dot here, because each dot is 1 standard deviation. Now what happens is, or what you're going to see is, what if you land between the numbers? Like, what if you land not at 7, because 7 would obviously be easy. It would be 1.5, because that's between 6 and 8. But say we had 6.3. Okay, how would you know then exactly the exact position? And that's what we're going to talk about. That's what we call Z-score. We'll talk about that in a minute. Okay, number 2. How many standard deviations would a dog would be at 10 years old? What would you say? 3. Okay, that's pretty simple, because we can read those exact numbers right from our bell curve. And how about 4 years old? At 4 years old, you're right at the mean, so we haven't moved, so that's called 0. Okay, you haven't moved at all, so you're right. If you're right on the mean, that's 0. And then for number 4, how many standard deviations for 2 years old? 1 standard deviation. Okay. Number 5 says, how many standard deviations away from the mean is a dog that is 7 years old? Well, like I said, mathematically, we can tell that, well, 7 would land between 6 and 8, right in the middle of 6 and 8. So what would you say the answer is? 1.5. Okay. Now, I'm going to show you how you can get that by using, give you a second, the Z-score. Okay, so here's the Z-score formula. Everybody write it down. Z equals X minus the mean divided by sigma. Because we're going to have some numbers in a few minutes that we're going to actually have to use this. Now, 7 was actually easy to see that it's between 1 and 2, so we said 1.5. But this will give you the 1.5. So this is what you would do. You would say Z equals, okay, my number in the data that they asked me is 7. This is your X right here. So 7 minus 4, which was our mean, divided by our little sigma, which is our standard deviation. We were counting by what, 2? And of course, 7 minus 4 is 3. 3 divided by 2 gives us the 1.5. Okay, so that is Z-score. It tells you exactly where you land on the bell curve. Okay, that's the whole point of the Z-score formula. Okay, so anytime you see Z-score, especially when you guys are taking your test, you automatically want to look at your formula sheet and make sure you write down the formula and then solve for whichever variable you're trying to solve for. In this case would be Z. All right, let's move on to the bottom part here. Okay, in this table, we're using the Z-score formula to find out the position that 3 would fall on the bell curve, 2.6, and 7.5. So technically, all of these numbers in this column here would be considered your X of I, your individual data points. So the first one is already done using the Z-score formula. So we're going to fill in the other 3. Okay. So here's our formula here. So this time my X value is 3 minus the mean, okay, divided by 2. That's going to give me a negative 0.5. 2.6, we have 2.6 minus 4 divided by 2. That's going to give me a negative 0.7. Okay, and this obviously is just for practicing purposes. And then we have 0.75 minus 4 divided by 2. That's going to give us a negative 1.6 something. Okay. All right, let's move on to the next page. And that's just practicing using the Z-score formula. Now, this is a very good question here. Okay, take a look. So this particular question asks, a teacher gave a quiz. The following stem and leaf plot shows the scores in her class. So they had 40s, 50s, 60s, 70s, 80s, 90s, and, you know, one person got 100. So it says the mean score of this data set is 70. So where do you place the 70 on your bell curve? In the middle. So here's 70 right here. Okay, that is your mean. So the mean is always right in the middle. And the standard deviation, rounded to the nearest tenth, is, what is that, 15.8? All right, so our standard deviation is 15.8. So I'm going to put 15.8, which is our scale. So now we need to count to the left 15.8. So each standard deviation will be plus 15.8 from 70. Going to the right and going to the left, we'll subtract 15.8. Okay, so 70 plus the 15.8. Okay, this will give us 85.8. Okay, that will be one standard deviation. All right, so two standard deviations will be 101.6. And really, guys, I don't really need to do the third one because no one got over 100%. All right, so technically, according to the stem and leaf plot, the highest score was 100, so I really don't even need to do the third one. Okay, let's go to the left. So we'll take 70 minus 15.8. Okay, that looks like it gives us 54, what did you guys get? 54.2. And then what was the two standard deviations? All right, so we're going to stop there because no one got a lower score than that. Okay. All right, so let's just take a look and see what the question is asking. it says which scores, okay, this is a good question because actually I think we got this off an old SOL release test. Which scores fall within one standard deviation from the mean? So when it asks you that, they mean one to the right and one to the left. Okay, just don't go to the right. So you need to find out how many scores fall within. So what's our range? 54.2 to what? 85.8. That is within one standard deviation. So you need to tell me how many scores would fall within this range here. That will be within one standard deviation. Okay, so let's take a look. Okay, can I count any of the 50s? No, because it's not 54. So I'm going to start with the 60s. So I have 1, 2, 3 here. How many 70s I have? 1, 2, so that's 7. I can count the 80s. 8, 9, 10. Can I count the 90s? No. So how many scores fall within one standard deviation? 10. Okay, and that's how you would figure that out. Okay, that's how many scores fall within one standard deviation. Okay, second one is also one that we got from an old SOL release test, so let's take a look at it. So it says the data set has a mean of 16.5, and a lot of times, guys, you know, as soon as it says that, you need to go ahead and make your bell curve. There's your mean. Here's your standard deviation. They said you're counting by what? 3. So that's going to give me, what, 19.5? Okay, what would this one be? 21, 19, 20, 21, 22? Okay. And what would the third one be? 25.5? All right, how about going to the left? 13.5, what else? 10.5 and 7.5. Okay, so let's see what the question is. It says, and this one actually, you know, it says the element X has a z-score of 1.5. Well, guess what? If it's 1.5, and this is 1 standard deviation, and this is 2 standard deviation, wouldn't I be between these two? If this is 1 standard deviation, this is 2 standard deviation, so where's 1.5? In the middle of 1 and 2. Is that a true statement? Yeah. All right, that's a true statement. So it says, so which interval would that particular 1.5 lie in? So here are my two numbers right here. It's going to lie between 19.5 and what? And 22.5. Here it is right here. This would be the answer. And like I said, this was an actual question. Okay, so if you do a nice visual, you can actually see where 1.5 would land on your bell curve. It's between these two intervals right here. Okay, but you got to understand the bell curve and be able to create that bell curve as a nice visual. Okay. All right. Let's take a look at the last question on this page. Okay, it says a set of data has a mean of 34. So where's the mean going to go? In the middle. And this time the standard deviation is 4.5. So now this says, look at part A. It tells you a z-score of negative 1.2. Without doing a calculation, state whether this element is less than, equal to, or greater than 34. Okay, so I want you guys to pay close attention to this. If the z-score is negative, then that means I'm on this side of the bell curve. Okay, because this is -1, this is -2, and so on. So if the z-score is a negative 1.2, I have to be somewhere in here. Because here's -1 right here. Correct? So the question is, without doing any calculation, would this element be less than, equal to, or greater than the mean? It's going to be less than the mean. Okay, because these numbers have to be subtracted. You have to subtract 4.5 So these numbers here will be smaller than the mean. Okay, so we're going to put less than for that. Okay. All right, so now it says determine what that number would be. So this is where we're going to use our z-score formula. Everybody write down the formula, x minus mu divided by the standard deviation. So we're going to put in all the numbers that we know, and we're going to actually be solving for x. Okay, we know the z-score. What did they tell you the z-score is? Negative 1.2. We don't know x, so we're going to leave it as x. We do know the mean. What is the mean? 34. And we do know the standard deviation of 4.5. Okay, so I'm going to give you a second to go ahead and solve for x. All right, so we're going to come out with what? 28.6? All right. So that would be the actual element that would land at negative 1.2 as a z-score. Okay. All right, so let's move on. This is page 10, and I believe I have you guys, let me check my agenda. All right, so you're going to be doing pages 11 and 12 for your classwork. Okay, I'm going to do a couple problems on 10, and then your homework will be pages 13 and 14. All right, so I'm not going to do all of page 10. We're just going to concentrate on a couple of these. Okay, let's look at question number 3 and 4. So it says the length of hair of a private in the Marines is normally distributed, that means like a bell curve, with a mean of 1 centimeter and a standard deviation of 0.3. Now you really don't need to make the bell curve here. You definitely can, but you don't really need to, because based on what they're asking us, it says private workman's hair has a z-score of 2. So how long is his hair? All right, so that means we are solving for x. Okay, so we're going to write down the z-score formula. Okay, and then we're going to put in everything we know. We do know his z-score is 2. Okay, we don't know how long his hair is. And we know the mean is what? 1. And the standard deviation is 0.3. All right, so there we are. So now we need to solve for this again. Okay, so I'm going to have you guys solve for x and let me know how many centimeters his hair is. Okay, I'll wait. Okay, yes. All right, 1.6 centimeters. Okay, we're going to do the same thing for McLeod's hair. It is correct. It's exactly what I have on my paper. All right, let's take a look at Private McLeod's. So we're going to say his z-score is negative 1.8. Well, guys, actually, I already know by him having a negative z-score, his hair is going to be shorter than the mean. Okay, because it's on the left side of the bell curve. Okay, just thinking out loud. So negative 1.8 equals x minus 1. Okay, divided by the 0.3. Okay, I'll wait for an answer for this one. How long is his hair? Yes. Very good, 0.46 centimeters. So who needs the haircut? Private who? Workman. Okay, his hair obviously is longer. Okay. All right, let's take a look at number 4. Okay, it says the number of crackers in a box of cracker box. Crackers is normally distributed. Okay, so the mean is 75. So everybody put 75 in the middle. And the standard deviation is 2. So I'm counting by 2s. So this will be 77, 79, 81. Okay, I don't really, and I'm looking to see where 82 falls, so I really don't need to go to the left. Okay, so it looks like it's going to be definitely have a z-score that's greater than 3 standard deviations to the right. Okay, so Mrs. Finnegan, she wants a box with exactly 82 crackers. So what is the z-score? So let's write down the z-score formula. Okay, so this is going to give me z equals 82 minus 75, because she wants 82, that's your data. Divide that by 2, what do you guys get? 3 point something. All right, so 3.5, and we knew it was going to be greater than 3 because at 3 standard deviations, you're at 81. Okay, and we probably could have figured out 4 would have been, you know, and then halfway in between. All right. Okay. All right, guys. So